This reluctance motor, I think, was one of the most important motor you should learn. And I found that most of the other universities, they only teach you about DC motor, maybe induction motor, but they seldom show you about switch reluctance. Switch reluctance motor happened to be really old motor, actually developed earlier than induction motor. I think the history could be more than 200 years. But however, it's also a future motor. The nobody is from, they don't understand how to operate. And the advantage is much better than all the motor you learn in the past. So after these two lectures, you understand why I say it's so wonderful. This motor is so wonderful, so beautiful to say. If you want to use motor for the future, vehicle, robot, maybe aerospace, everything, you should only use this motor, not the other motor. So throw away all the things you learn. This motor is for no use rubbish. Only this motor is so important, so nice. So now you follow my lecture, you know how good this motor is. The concept here is simple. The configuration is simple. The operation is simple. Everything is simple. So that's also really low cost, much cheaper than all the other motors. So that's why I highly recommend you to focus on this field lecture. It's so important because no other university teach you this SRM. I've been working for SRM more than 30 years. I think the count of publication and the highest number of publications in SRM among all the professors in all the universities. So if in the future you like to do a PhD in motor, you should follow me to do SRM. Still so much work ongoing. That is a future motor, not today's motor, it's a future motor. The motor is already 200 years, nobody has done any work. It's so wonderful. So now that we're going to show you the basic configuration, the schematic principle, and all the top equation. All the equations are quite simple, straightforward. The configuration also so simple. Yeah. So let's see our target. What we try to ask you to learn. You see all the motor we are now learning in the class at PM, permanent magnet. Can you tell me what's the disadvantage using permanent magnet in a motor?
Can't carry the flux to the rotor.
Or what else? There's so many comments. What's the effect? Is the drawback for using PM?
Doing cost a lot.
Cost a lot, yeah. PM is really expensive. Firstly, you need to use a rare earth material. Rare earth material is really expensive because another thing will be if you want to make a really large, huge motor, your PM needs to be really huge. How do you make a PM so huge? When you make the PM, you need to use a really high press machine to press all the components, press them together, high density. Then for small motors, small machine, magnet like what we learn, the concept is quite small and very low cost, but huge magnet is really expensive, impossible. You can't make any large motor using huge magnet, impossible. What other drawback? What do you think? Heavy. When you do the lab, when you holding those PM, what do you think? And then can you try to drop the ground? The break research. Oh, there's really central actually. You can see that a motor be used in certain rotational or vibration environment. Then the PM will break after operation. If the PM break, then you can't have any operation. I think in the high school you learn the PM under the high temperature. Yeah. A motor actually, what kind of temperature you're talking about? We go to 80 degrees, maybe sometime when the motor is running for a long time. When your vehicle put it outside to the sunlight, go to 60 degrees. And then if you run the motor, you get even higher temperature. And then in the winter, go to minus maybe 20, minus 30 degrees. So the high temperature range will denumerate the PM. So you may see that your motor is running really well today. After a few years, demonetization, vibration. So all these things will cause a problem. And another problem is when you use the PM motor in the robot, they always have a magnitude in there. So we may magnetize other component. If you use them for some security project, you don't have the PM, the magnet is detected by other sensors. If you use them for some special purpose, maybe as some security purpose, you don't expect any sensor detect your PM field inside motor. If detect, there must be a motor. There must be a robot or vehicle to be found. So that means a motor with a PM inside have a lot of inconvenience. So that's why, firstly, most of robots today, they tend to use the PM motor. That's not a good move to do that. And robot, say vibration, temperature variation is not good for PM. So now, so next question would see which motor you think have the highest speed? You have learned so many motor, which motor have the highest speed? You think permanent magnet DC motor? No, because the carbon brush commutator, once you have contact, the speed cannot be too high. Now in that motor, the contacts, you think the high speed of the industrial motor. Permanent, this is a good thinking because the contacts. And then still not yet. Why I say that? Because permanent is the magnet is stick to the rotor. It's quite heavy. I want the high speed means the rotor must be really light, no inertia. So that's not be the criteria. Industrial motor also have the rotor winding. And also industrial motor is not synchronous. So there are synchronous related to catch up with the speed. So all the motor developed is not really high speed, only SR motor. That's the high speed in the world. No one can beat that. So he want to design motor, use a motor really high speed, 10,000 RPM, 30,000 RPM, 36,000 RPM, only SR and switch reluctance. Fault tolerance. You see, when you use all the motor, like vehicle industrial motor, you got 3 winding, maybe 6 winding. If one winding is broken by any mistake, what happens to the industrial motor? Short circuit. That's not working at all. Impossible for the motor. Because if they need to be symmetrical, so any one winding is broken, impossible. This motor got armature and 2 winding there. If one winding is broken, or the 3 winding is broken, of course it cannot work, impossible. But for SR motor, then we have so-called fault tolerance. Even though you got 8 winding, a few winding is broken, it still continues to work. Unlike a motor, which so-called the fault tolerant capability. So fault tolerance is so important for motor for safety. You see, if I use the SR motor into the robot, even though I feel winding is broken by any fault, the robot still working. If you use this motor for this vehicle, setting a winding broken, say industrial motor, the vehicle cannot control, it becomes disaster. If you use 4-wheel drive, one wheel is broken, then the vehicle will circle around in the same spot. But for SR motor, we don't have that problem. Even though 1 winding broken, 2 winding, 3 winding, 4 winding, and this 2 winding left behind still continues to work. So, and that's why we like something to be really reliable, really highly reliable. Only SR motor can able to do that, really 100% reliable. So that's why we use SR motor for the flight control system. Today, all the flight control system, they move on, they gradually catch up with this technology for the SR motor. In the past, they may use DC motor, personal DC motor, the industrial motor, but now this whole technology. So we now move on to SR motor. And also, unlike motor becomes simple structure, the industrial motor is quite complicated. Stator, rotor, and so many motor bar with multiple phases in the rotor, really complicated. And the concept is really complicated. So it's something simple that means easier to control, easier to operate, easier to maintain. So operate industrial motor is not a good choice, right? But SR motor, really simple. Next week, about the cost. Which motor you think the cheapest, lowest? PM motor, motors.
That would be like the brush DC motor, be the cheapest.
Brush DC motor has been there for a long time, but the main thing for brush DC, because PM is really expensive. The most expensive component in the motor is the PM, permanent magnet. So that's why it cannot be too low costs. PM need to use rare material. In some time in future, after about say 15 years ago, sometime there was some restriction in the PM material. So at that time, all the PM motor become really expensive. Like during that time, we tend to use wind power generation. During the time we use the PM for the wind power, then we just cross all the wind power the operation stop because the motor is too expensive. So that's why, but we do have a solution. This is SR motor, really low cost, really simple structure, no PM at all. The winding, in this motor, we got winding the stator and rotor. This motor, we only have one set winding in the stator, no winding in the rotor. So we do the cost for the coupler. We also don't have to use PM. So that's why this motor is cheapest motor among everything. So all these things will come up with the why I say that this is a future motor, so wonderful, everything is good. Yes.
What about in terms of torque? Is this like high, low, medium?
The top also really good, very high form. They don't show the top equation. And of course, setting is so good, there was something shortcoming. So what do you think? What's the drawback for this motor? I can't have everything 100% good, right? What do you think the issue for this motor? Why? So as I said, this motor has been 20 years old. Why nobody is using it? What's the problem? You have diesel motor, industrial motor, everybody using it. But why nobody using this motor? Impossible. So good, so low cost, so reliable.
That's it.
So after this lecture, then you know the answer. So let's see. Good. So we got 13 chapters. We divide them into 2 lectures, and for this week and next week. So we firstly go through the principle, and we make use of induction for the motor to process the motor. We also show you the torque equation, and we do have the base control and also steer pole. And later on, for the next chapter, we go for the motoring and the magnetic flux operation, and also the motor drive, how to control drive motor, and also some basic feature and application. Then you can see how we're going to apply the motor to other applications. So let's start to understand more about it. I found that many universities doesn't quite care about the SR motor. The thing is, one thing will be this motor do require power electronic to drive it. Without power electronic, it doesn't work. So that's one of the reasons the motor has not been attended by many other users. Because you can see DC motor, you can use pure DC, the motor can move. You can use variable DC voltage, the motor can operate and control DC motor using pure DC. You don't need power electronic, you can work with this motor. Even industrial motor, you only need AC source, the industrial motor can work. You don't need to use inverter.
So is the downside is it needs power electronics to work?
Yes. This motor, the downside will be use power electronic. You must use power electronic to make it work. Because power electronic only DC or AC it doesn't work. So that's one of the reasons that this motor will be developed quite behind the other technology, because in the past, the people only constantly focus how to use the motor using pure DC source, DC source. They may start to convert them in power electronics, but they did not catch up using power electronics for SR motor. So therefore, the downside, you have to use power electronics. But for last 20 years, power electronics have developed, so that's the time to use this motor. So let's see how we use power electronics to control the motor. So firstly, this motor, we don't have any rotating magnetic field. That means we don't need to use field winding. We don't need to use the stator winding to create the magnetic field. Simple enough. And then we don't need to have a DC magnetic field like this motor. We don't need to do that. And then when it stationary, putting there, no magnetic field. So PM, I don't like that. When it's stationary, there's magnetic field, it may affect other components, it may be detected by other sensors, which are so deadly for some dedicated condition. We don't like to use PM motor. And then this is the switch reluctance motor. And then we based on another new principle, that's not based on the Lenz's law, like the Lorentz force. We don't have that principle. We use another principle to divert the motor. So what you learn using this, you don't have to do that. And because it doesn't use the Lorentz force to do that. And then no commutator and no brushes like this motor. You have no slip ring, you get the same motor, so without anything. So that's why, but however, this motor has been developed for a long time, at least 200 years. During that time, we have no electronic, I don't know how they developed that, but from the internet, they say, oh, developed 200 years. I don't know how to operate. They developed motor, but don't know how to operate. So funny. So, and then, but the development is so slow because during that time, we don't have power electronic to control that. So that's why it become a major problem. The development is so slow. One thing would be this motor at the moment it's more expensive because it's not mature product. We don't have that many manufacturers. So anything low body to manufacture must be expensive. But this motor, industrial motor, so many people are building that. So that's why they already mass production really low cost. Although this motor don't need to use much material. All the material for the motor is really low cost, but still really expensive because nobody manufacture. So after this 2 lectures, I show you how to do that. You can build up your company to manufacture this motor to become rich. Or you can use the motor for mobile, electric vehicle, aerospace, aircraft design. They all need to use this future motor. Anyway, so the principle, we are not using Lorentz force, we are not using the Lenz's law, we don't need to use the rotating magnetic force, we use a principle called variable reluctance. This variable reluctance able to create us with a variable reluctance force to do that. So that to say we try to energize the motor with the stator winding, create a reluctance principle to force the motor to rotate. So that's to say we don't need to have any stationary thrust, we don't need to have any rotation thrust. So the torque are generated by turning on those stator winding. We do have a stator winding in the motor by turning on and off to control how we change the reluctance of the motor. Once we can change the reluctance, we can able to generate reluctant force. And then to do this, one of the principles here will be try to minimize the reluctance. Later on, I show you what the reluctance. We know the reluctance from engineering 65, right? About magnetic. But here, this reluctance is called magnetic reluctance. We try to minimize the reluctance to generate the force. So in this case, you try to later on you can see there's a pole alignment between the stator and rotor. When we align them, we create the force. So the feature was quite special. We try to make sure the magnetic thrust inside the stator magnetic thrust, you try to conduct in the shortest path. When the path becomes shortest, you try to use the magnetic thrust to move the rotor to rotate until the path will be shortest. So that's one of the principle, the shortest path and the lowest resistance path to do that. So that's the principle behind how we able to move the rotor without any magnetic field. We only using reluctance principle to do that. So here you can see this one sample. The configuration is really simple. We have 2 metals there. One will say that right there. So this metal we have 2 windings here only. And the motor with another cylinder pole with some kind of hole here. That's it. We have no winding here, no PM here. We just put that inside, then you become a motor. So that's a really simple structure. Everybody understand it. The principle is so simple. It's so simple compared to diesel motor and industrial motor. Industrial motor, I think you find it very confused after 5 lectures, right? Still quite confusing, but it's so simple, very simple to understand. The equation is simple, everything is simple. So inside here, we're still using the laminated steel. So that means laminated steel is to reduce the eddy current. All the motor we use laminated steel. Like in that motor, this motor as well. So that will be the same. But key thing is no winding, no permanent inside the rotor here. Even though low PM inside here too. So that's to say we don't need to worry about the weak link. In the past, all this motor, the link is quite weak to link between the state and rotor magnetic flux. So we don't have that happen anymore in this motor. We don't have slip ring like the single motor, like the round motor. So all the contact point and not reliable, and also there will be power losses, there will be spark, and also this aging maintenance with all don't like that. So this motor have low maintenance, so no spark. So that's why I make the motor very reliable and low cost, because only two pieces of metal, that's all, and with some winding. So you can see that this motor, the structure is simple, easy to make, and only a winding and two pieces of metal. That's why I can say that this metal is very straightforward. So let's see the configuration. So this cross section for the motor. So we have some salient pole here. So we put a winding here. When you put winding in this pole, we energize, fulfill the, once put in the current, we can fulfill the magnetic flux between the intent fulfill the magnetic flux. And then we got a rotor here. The principle here will be once we energize it, the magnetic flux try to complete the loop here. Then if this slightly move to that side, then the magnetic flux tend to use the shortest path to complete the magnetic flux. All the magnetic flux they need to complete the path. They can't just go to air without return. So to do this one, the magnetic flux, say if you're riding here, the magnetic flux will try to complete the loop, and probably will go through in here, the shortest path. Shortest path will go through here. And then return. So return, you force the rotor to rotate to this alignment so that we can have shortest path for the magnetic path to pass through. If not doing that, like in this other motor, like here, they will move this thing to here so that you can pass through the shortest path to do that. So that's the principle. The rotor you rotate until you meet the shortest path to conduct the magnetic flux. So that makes the motor rotate. That's so-called the variable reluctance principle, reluctance force. Yes.
So it's hard to take other motors and yet it's 16 in order to start rotation.
That's a good question. We do have a lot of combination. They don't show you what's the best combination to make sure the motor can rotate properly. And then there's a more, they don't you can see that. Just in here, just show you the principle behind how we're able to rotate the motor, because we're using the principle shortest magnetic path to do that. So that means we do have a winding on here. So for instance, you can see that we got 4 poles here, then more look like 2 phases, because these two are connected, these 2 winding are connected together, and these 2 winding are connected to another phase. So every time when we energize them, we use the power electronic to power up these 2 winding so that they fulfill the magnetic flux. And then the motor will be to here, we stop the current. Then no magnetic flux here, and then we energize this 2, we attract this one to rotate to here to complete the magnetic path. So that's how it looks like. So behind some principle, we mainly try to make sure the rotor can conduct the magnetic path between them. So that's how we call the variable reluctance. The reluctance means is the magnetic path here. The reluctance for this magnetic circuitry, including this reluctance, and this air gap reluctance. So when we try to close up the air gap, less air gap between them, then we got less reluctance. You can see that in this part, we got really large air gap, the reluctance will be really large. Then the magnetic flux will not do that. But however, if we energize this winding, disconnect this winding, the rotor will rotate to here to catch up with this shortest path. So there's some principle behind. They will try to rotate until the shortest path is able to achieve. Yes,
So in this case, would it be possible for the road to get snapped?
yes, that's a really good question. So in next few session, I'll show you, we will get stuck, how to avoid them, how the design between the stator and moving pole can avoid that stuff. So that's a really good question. So that's why this geometrical design are not of the issue here. We need to think about how to design number of poles in the stator and motor. The combination is quite special. So that's the thing we try to learn. So, yes.
Sorry, so when it's in the orange area,
That's the copper winding.
yeah, and it wants to move. Like, also, I'm confused, like, what it's called, the rotor, if it's turned to the area where it's orange, does it not have current flowing? Because it doesn't have the magnetic.
Yes. Like it here, when we energize this winding, this winding, we have magnetic field, how to complete this magnetic loop. Yeah.
Yeah.
Because what we got the rotor here, the magnetic part can be able to complete the magnetic loop here. So in this case, the rotor will stay here.
Yeah.
But once it stay here, then we don't like to stay here forever. So we disconnect this current using power trying to turn off. And then we turn on this current. Then every time we turn, then we try to complete another magnet. But after this too large air gap, then the rotor will continue to rotate. Because when the rotor rotating, it won't stop instantly. The rotor continue to rotate until you try to match up with this part. That's the shortest part. So that's why you have to analyze this one to make the rotor rotate to here. Next, we turn off this one, energize this one, rotate to there. So continue to do that. But that's the simplified diagram to show how it works. But actually, we got more complicated diagram to show more detail the arrangement between the stator pole and rotor pole. Yes?
Yeah, but that's one question, like this is just a simplified diagram.
Simplified
It's
diagram.
actually practical.
Yeah, this not working really well, but so the simplified diagram, you're able to show you how roughly how it works. But we do a lot of the other combination to show you more detail. That's design. We have so many different kind of design for SR motor, but that's one of the not good design, but show the principle. So now then we can generate the force by switching the stator, and then in order to pull the motor pole. Obviously, you can see that's a really simple structure, and then we can make it very robust and simple rotor. So this is a really simple rotor, very simple configuration, only metal, silicon, and iron there. No brush, no commutator, highly reliable, low maintenance at all. Because wherever your PM, you have maintenance. Wherever your PM, you worry about temperature variation, vibration. This one doesn't have problem. Why I say this is highly reliable? This shows you only two phases, right? But of course, two phases can rotate, but we have higher top level. But you can see that even though this phase is broken, this phase working, the motor can still continue to rotate, energizing this winding because you try to rotate the rotor until alignment, then turn off, then the next alignment and so on. Of course, there's a two phase, they use three phase, four phase, five phase. So in this case, when you have four phase, one phase broken, is still the other three phase can still continue to rotate the rotor. That's why this kind of the motor will be really reliable. Even though after winding is broken, it doesn't matter. It just loses a portion of the motor torque, but it's still good. That's why we use this motor for flight control system. We must make sure they're highly reliable. Flight control system, like the secondary flight control system, like to control the wing, then that will control the braking, steering, and maneuvering. Then we need to use that because flight control system must be high 100% reliable. So that's how the structure look like. Actually, the motor really look like this. So that's another arrangement. You can see. So tell me how is the difference this motor compared to previous one. Now you can see the winding is inside, right? So what's problem for this motor while the winding is inside not outside? Do you think the problem for the winding connection become the you sleeping for that reason? Why is that? What kind of motor? What kind of motor? Is it a still SR motor or why I put that here in this page called reluctance motor? Any comment?
Moving magnetic field, I think magnetic field will be moving down.
It's exactly the same thing for still SR motor. Still we have no PM here. Only have one set of winding. The winding only appear in one block here. We have no winding here. So confirm this must be SR motor.
The
No
outside
PM.
rotate, the outside rotate instead of the
Outside rotate. What applications outside rotate?
like wheel or something.
Motor wheel motor. Like the wheel. We call it the in wheel motor. So this one of the real good application for in-wheel motor. So we just flip the motor inside out to become a in-wheel motor. For motor wheel, for automotive application, we of course center connect to the shaft is stationary. So all the winding connect to the shaft, connect to the winding here, outside connect to motor wheel, then become our in-wheel motor. So we usually design the electric vehicle by using this motor. So outside for rotation inside connected shaft. So in this case, you can eliminate all the what we call it direct drive. You see the conventional motor, if you only the internal motor shaft rotating, how do you connect the wheel? You need to have a lot of the mechanical subsystem to do that. So you're raising out of the mechanical material and also each part has some efficiency problem, don't have really high efficiency. But this one here, embedded the motor inside the wheel, so this is our rubber wheel. You can see that everything, you don't have any mechanical losses. So this motor is one of how we design the electric vehicle. My electric vehicle, I use this kind of concept to design them, so we don't need to use clutch, no gearbox, no shaft, no transmission. Just directly embed the motor inside motor wheel. That will be wonderful, right? Yeah, then if I can have 4 motors here, individually control the rotation, I can have 100% 4-wheel drive. So for instance, I want the vehicle to be sport turning possible, side turning also, everything will be possible. But today, our digital vehicle or automobile, especially car, only a single engine to control 4-wheel. It's not really 4-wheel drive. The vehicle you're driving, say 4-wheel, they're not really 4-wheel. They only emulate 4-wheel. So this is how we use the motor for electric vehicle called the in-wheel motor. Anyway, so this is another configuration show us how to work on the SR motor. So both stator motor have stated poles, so that will test all the certain poles. So the principle is you also need to move all the motor around become outside motor to align with in order to make the alignment and also the rotation. Oh, sorry. Oh, but it's too exciting to show you the future motor. So do follow my work here. I like to all learn this wonderful motor. So wonderful. So beautiful motor. Okay, see you again next week.